Alright, now in example 4, sometimes you are asked to use the explicit formula. Okay, and how would you recognize the difference between the explicit and recursive? Well, if you're not given a list of terms, it's pretty hard to define it recursively, or find the next term recursively, because it's kind of hard to figure out what the previous term was if you don't have a list of terms, or if you don't know at least one term. So sometimes you are given the equation, and you're given basically the function, right? So think about it like this: a sub n is 3n plus 1. That's basically the same thing as the function f of n equals 3n plus 1. The difference between those two things is this. This has a domain that is the natural numbers, 1, 2, 3, 4, 5, 6. This has an unlimited domain. It can be 1, it can be 1.2, 1.3, 1.01, right? It can be any number that you can think of, including negative numbers, whereas a sequence is specifically restricted to whole number integers, positive integers, right? The natural numbers. So it says find the ninth term in the sequence by using that formula, and then graph the first 5 terms in the sequence. All right, so we're going to start by quickly doing the ninth term. Here's how you do that. If I want to find a sub 9, then I literally replace the n with a 9, so I replace the n with a 9. So 3 times 9 plus 1. And that is a sub 9. The ninth term in this sequence is 27 plus 1, which is 28. Right? So, how would I find the first 3 terms? First 5 terms, so I can compare them. Okay, so A1 would be 3 times 1 plus 1, which is 4. A2 would be 3 times 2 plus 1, which is 7. A3 is 3 times 3 plus 1, which is 10. And as we figured out before, this is a pattern that we're setting up here, so hopefully you're seeing that we're adding up by 3s, which means A4 should be 13, and A5 should be 16. Okay? You feel free to go in and check my math there, but now it says we're supposed to graph these, so I'm going to draw a very quick graph. Since everything is positive, we can stick to the first quadrant. I think I'll count by 3s. So 3, 6, 9, 12, 15, 18, 21. Okay? And then 1, 2, 3, 4, 5. Again, just graphing these first 5 terms. And this is something I want y'all to get a little bit better at, so I'm going to specifically practice it here. It's easy when you're plotting points, but notice that our slope of this would be 3, right? So that means every time I go up by 3, which means up 1 line, I go right 1 line. Some of y'all have been trying to graph and say, oh, the slope's 3, I need to go up 3 lines. Well, you're actually going up 9 if you do that, the way the graph is drawn. So make sure that your slope is represented by whatever your labels are on the x and y axis. You have to be very careful with them. All right, so anyway, regardless of plot points, it's pretty easy. So 1, 4, it can be a little bit above 3 there. 2, 7, 3, 10, 4, 13. You guys, I know, I mean, work with me here. I didn't label it perfectly, but you can certainly get the idea. And what you should see is that this is linear, and it should go through a point. Okay? All right. Next example. Find the 7th term in the sequence given this. And this is a sub n equals 3 times 2 to the n minus 1. We're dealing with exponents. That's a hint right there that is what you would call a geometric sequence, which we'll spend more time talking about later. But we're repeating multiplication here as opposed to repeating addition. Repeated addition and subtraction is arithmetic sequence, and repeated multiplication is geometric. So those are really the only two types we'll talk about here. So you don't have to stress too much. Just know arithmetic, addition, geometric, multiplication. Okay. All right. So again, that is the same thing as saying f of n is 3 times 2 to the n minus 1. Okay. And we're looking for the seventh term. So I want to do f of 7. Again, the only difference between these two things is the domain. All right. This, as the restricted domain to the natural numbers, this could be any number. Okay. So that's the difference. Oh, and one thing I did catch myself on last one. I should not have connected any of these points. I got such a happy little moment of trying to graph that I wasn't thinking about it. Okay? We cannot graph these points. Okay? Because our domain is restricted to just the numbers themselves. Right? We just talked about that. So my bad on that. Alright, and then back to this one. So I want to find A7, seventh term in the sequence. So 3 times 2 to the 7 minus 1. Again, order of operations, that's all in the exponents. It's like having a set of parentheses there that has to be figured out first. So A7 is 3 times 2 to the 6th. Okay? So figure out what 2 to the 6th is. And remember, you cannot do 3 times 2 would make that a 6, and do 6 to the 6th power. That's not the same thing. Okay? So you have to do 2 to the 6th power, which is 64. So this is 3 times 64, which is 192. Wow, that didn't work out very well at all. Let's try that again. 192. Okay? Now it says graph the first 5 terms in this sequence. So let's figure out what the first 5 terms would be. So A1, okay, would be 3 times 2 to the 1 minus 1 power. Well, 1 minus 1 is 0, right? So we're doing 3 times 2 to the 1 minus 1. So that equals 2 to the 0, which is 1 times 3, which is 3. Right? A2 would be 3 times 2, 2 minus 1. So 2 minus 1 is 1. 2 to the first power is 2 times 3, that's 6. Okay? And since I told you just repeat multiplication, what are we multiplying by? 3 times 2 is 6. So it should be doubling every time. And notice the thing that's right here, the base, that's the thing we're multiplying by. Okay? So 3 times 2 to the 3 minus 1, that would be 2 squared, which is 4 times that is 12. Okay, and now you can see your pattern, that's the third term. So A4 would be 12 times 2, which is 24. And then A5 would be 24 times 2, which is 48. Now, to graph that, again, no point going anywhere other than the first quadrant. And I think this time, just to make my life easy, I'll count by tens. And again, I'm just quickly sketching out this graph. Okay. You can feel free to spend more time using graph paper on yours. So 1, 3, that's going to be really low. Give me my chart here. 2, 6, that's also going to be pretty low. 3, 12. 4, 24. So all the way up to here on the 4. And then 5, 48. Okay, what you should see is whereas the last one had a general linear shape, straight line, this one has more of an exponential shape, more of that curve sort of shape. And we'll do a lot more with this later on in this unit, but today we're just kind of trying to get a general understanding of these sequences and these recursive and explicit formulas. So, you still have some questions about it, that's fine. Make sure you ask me. Again, this stuff will come back, so make sure you get a good understanding of it now. Okay?